So in the last class, we did oxidation states, right? So in oxidation state, today we'll do a few questions regarding oxidation state, and then we will look at magnetic property and a few other properties of D block elements, and the D block elements will be over. And then tomorrow from F block elements, there are two different series. There is a lanthanoid series and an actinide series, from which actinide series has been struck off the syllabus. So we will just do lanthanoid series. Okay. So hopefully today we'll be completing the D block and the properties of D block. And I will today start with questions on oxidation state. Okay. On oxidation state. Okay. Can all of you see the screen? Yes or no?
Yeah, sir.
Okay. Thank you. So please write the first question. Wait a second. My is not connected. Which of the 3D series elements show +1 oxidation state and why? So I think we have written the oxidation state. Yes or no? The general oxidation state of different things. Yeah, you have written this now. So you just go to that table and look which of the following is giving +1 oxidation state, and then we will think about why it is showing +1 oxidation state. Okay. Write the question down. Look at the table that you draw in the last class. And I think you can identify at least which of, okay, what is also here. You can identify which of the elements shows +1 oxidation state.
Sir, only copper.
Only copper, right? So which of the following
Yes.
3D series? I think all of you got this, yes or no? Nazira, Sania, Fatima was here. Fatima got disconnected. Yes. Acha, Nazira, आप last class में थे? Were you present in the last class, Nazira?
No, sir.
No, you did not watch the lecture.
No, I was preparing my practicals, right?
Okay. You can come to the lectures. Okay, it is just like 1.5 hours or so, and also
Yes,
try
sir.
to.
I'll watch. Yeah.
So which are the following? So copper. Na, copper shows +1 oxidation state. Na. Now, for the reason we will have to look at the electronic configuration. So we know that copper is atomic number 29, and it is argon 4s 1 3d10. Correct? Yes or no? And then you can write is hence it can easily lose. It can easily lose 4s1 electron to form, rather I should say, to give stable 3d10 configuration. Okay, so note this down. And the next question. Calculate the number of unpaired electrons in following. Calculate the number of unpaired electron in following. And which of them would be most stable in aqueous solution? Okay, so that I'm giving you some elements, or other ions, I should say. So you will have to calculate how many unpaired electrons are there in Mn3 plus, then write Cr3 plus, then you can write vanadium 3 plus, and then you can write Ti3 plus. Please don't wait for my answer. At least I want all of you to give me the unpaired number of unpaired electrons. Okay, refer to your notebook or something else to get the atomic number of manganese, chromium, vanadium, and titanium. And then you have to remove just 3 electrons from each of them, and you will be getting the number of unpaired electrons. Okay, please start doing this. Fatima, what is the atomic number of manganese?
25.
Okay. And what will happen if you remove 3 electrons?
20. 3d4 it will.
You have to consider that also, no? You understood it?
Yeah.
Manganese 3 plus, hai na? Okay. Ahmed, please write the A, B, C, D. Which question? Okay. Whatever the atomic number is, you have to remove 3 electrons because it is 3 plus, right? Manganese, vanadium, titanium, chromium, all of them. भाई आप लोग atomic number लिखो पहले. Right, give me the atomic number for manganese, chromium, vanadium. Yes, Nazira, correct. ठीक है. Please, I don't know what you guys are writing. फिर भी गलत है, लेकिन अहमद, your answers are completely wrong. Write the electronic
Sir,
configuration. हाँ बताइए.
I'm confused with this low spin and high spin. Like the elements, they will emerge or not?
Yeah.
The elements from the other table that will combine or not? I'm confused with that.
वो दो क्वेश्चन आंसर अभी जो लिखे हैं वो
तो
याद
कुछ है ही नहीं इसमें combination का. You just have to tell me. You have to remove the electrons and tell me how many unpaired electrons are there. That's it. Nothing
Yes,
else. Okay. In gas state, no, कुछ combination नहीं हो रहा है. Okay. This is it. By the way, Abir. This is it. Fatima, आप please electronic configuration लिखिए, and then you tell me how many unpaired electrons are there. Okay. I don't think you are doing it right. Yes, Sania, correct. What about Faisal? अच्छा, फैसल ने दिया अभी जवाब. नहीं 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 नहीं, you guys write the electronic. आप लोगों को नहीं आ रहा है. आप लोग ये समझिए यहाँ पे ना. फातिमा, can you please turn the mic on?
Yes, sir.
अब यहाँ कॉपर दिख रहा है आपको ना, यहाँ पे you have this copper element, right? Yeah. Now if I want to remove one electron, then कहाँ से निकलेगा? 4s or 3d? Where will I remove the electron from?
4s.
Okay, so you are removing the electrons from 4s in all of them,
Yes.
but still you are not getting right. Why is that? Where is your answer? Now please all of you don't give me one answer. एक बार please concise करके एक chat में भेज दीजिए. Okay, in one text. Take your time, and in one message you just send all the answers separated by comma. How many unpaired electrons are there? Then I will start doing this. Yes, Ahmed, correct. Just give me the unpaired electrons. Okay, Nazira, don't write anything else. Just give me the unpaired electrons. Manganese atomic number is 25. So this will be having how many electrons? This will be first of all.
22.
Yes. So in 22, 4 electrons are 3d4. No, I mean 3 plus will be 3d4, right?
Yes, sir.
Okay, fine. Then let me just show it all for you, please. Mn is equal to 25. That is equal to 4s2 3d5. Mn3 plus में you remove 3 electrons, so 4s2 all the electrons are gone, and in 3d5 1 electron will be gone, and this will be 3d4. That is equal to 4 electrons which are unpaired. Now in chromium 3 positive, there will be chromium is just chromium is what? just before manganese now, so it will be having 3d3. So 3 electrons are unpaired. And vanadium is just before chromium. Suc Tv. So Suc is scandium, titanium, vanadium, and chromium. So vanadium will be 3d2, that is 2 electron, and Ti will be 3d1, that is 1 electron. Okay. So Faisal, Fatima, Nazira, all of you got this, yes or no? Nazira was giving the right answer. Faisal, आपको समझ में आया? Yes, Faisal.
Sir,
हाँ बोलिए.
when do we know if we have to pair or not?
Why will you pair?
Like pairing will happen or not in
No,
other
no, no.
cases?
No, none of the cases pairing will happen, right? Why will pairing happen? Yeah, 5.
Yes.
B may 5 orbitals are there, now. Here we have
Yes,
4
sir.
electrons only. Why will be pair pairing? Okay. Now, next question is, which of the following will be more stable in aqueous solution? So I think we did this in the last class. We saw that chromium 3 positive, it will give me, since in aqueous solution, Cr3 plus will coordinate with H2O, and the d orbitals will split, leading to T2G3 configuration. Okay, and T2G3 configuration will be stable, and that is why hence Cr3 plus is most stable. Okay, half filled T2G3 is half filled configuration, that is why Cr3 is most stable. Please write this down, let me know if you're done.
Sir, could you explain the C part?
Okay, vanadium, what is the atomic number? What is the atomic number in vanadium?
23.
This will be 4s2 3d3, right?
Yes, sir.
So if you remove 3 electrons, all the electrons from 4s will be gone. 1 electron from the 3d will be gone. You will be left with 3d2, correct?
Yes, sir.
ये आप एक शॉर्टकट ध्यान में रख लीजिए, ठीक है? The number of unpaired electron will be the sum of the digits of atomic number. Okay, so you can see manganese is how much? Manganese is 25. So 5 plus 2 is equal to 7, and then minus the charge, that is 3. This will be equal to 4. Okay, so just to get it fast, okay, nothing other than that. You can say that it is just an observation that the number of electrons in 3D series now, this is only for 3D series, okay, number of unpaired electrons in 3D series. Okay, now ये भी नहीं होगा, wait a second, till manganese, this will be only till manganese. You can have this, yeah, only till manganese. After that it won't work, I guess. Maybe it can work for one more element after manganese, but not after that. The thing is the number of electrons in 3D series elements, number of valence electron, I should say. Number of valence electron in 3D elements is what? It is sum of the digits. Okay, so you have 21, 22, 23. So first of all, you have 3 electrons, then you have 4 electrons, right? Then you have 5 valence electron, and also this 2 is constant, and similarly 4s2 is also constant, and this 1, 2, 3 changes as the d electron changes. This is just an observation, है ना? इसका कुछ reason नहीं है. This is just an observation, nothing else. It is a coincidence, you can say, that it is happening, nothing else. Okay, done, guys. Now let me write another question. The transition elements. So higher oxidation states. To higher oxidation states in oxides and fluorides. Why? So the answer will be, what is special about oxides and fluorides? In oxides and fluorides, the metal is combining with oxygen and fluorine. Okay, what is so special about oxygen and fluorine? Oxygen and fluorine, these are the most electronegative element. Yeah, these are the most electronegative elements. Okay, and they are very small in size. So two things are fact, that if you have a metal and if the metal is combining with small elements, if the metal is combining with small elements, then it can combine with a huge number of small elements. And if this small element is going to be electronegative, then what it is going to do, it is going to impart a positive charge on the metal. It is going to impart the positive charge on the metal. Now, if the number of oxygen fluorines increases, that means there will be higher will be the oxidation state, right? And they are small, and that is why they can bind to the metal atoms very easily. They are very small, so a huge number of fluorines and oxygen can bind to the metal atom. Okay, so most of the higher oxidation states, these are shown by oxides and fluorides of the metal. So we write due to high electronegativity of fluorine and oxygen atoms, and also their small size. Okay, also their small size. You can give some examples such as osmium fluoride, V2O5. Okay, these are some examples in which the metal atom is going to show a high oxidation state. Okay, now next question is, the lowest oxide of transition metal is basic, and the highest is acidic. Okay, so write this question, why? Now it may seem that it is a question about oxygen, but it is not. It is not a question about oxides and all. It is a question about the oxidation state rather. Okay, it's a question about the oxidation state. Okay, lowest oxide and the highest oxide. Please write this question. Let me know if you're done.
Yes, sir.
Done, all of you? Okay. So I want answers from all of you. Okay, Abir, Fatima, Faisal, Nazra, everyone. When I'm talking about lowest oxide, then it will have a low oxidation state, correct?
Yes.
The lowest oxide, it will have low oxidation state and highest oxide. Yes or no? Fatima, Ahmed, Abir
Yes.
Yes, sir.
will have high oxidation state. Okay, will have high oxidation state. Now, let me move to this table here. Okay, the table that we drew. Now let us see manganese here. Let us see manganese. Okay, let us see manganese. Now, if I am in the +2 oxidation state, what is the oxidation state that I am currently taking? +2. Okay, so it is high or low? +2 is high or low?
Low.
+2 is low. Okay, +2 is low. Now I have a oxide of manganese in which the manganese is showing +2 oxidation state. What is the oxidation state of manganese in that oxide?
+2.
+2. Very good. Now, if it is going to react, okay, if the manganese is going to react, it can only move further down. Yes or no?
Yes, sir.
Right? So
Yes,
what
sir.
will happen? Its oxidation state can only increase. Its oxidation state can only increase. An increase in oxidation state is accompanied by what? How will something go from +2 to +3? By losing electron or gaining electron? Tell me.
Losing electron.
By losing electrons, right? Now it is losing electron. Then what kind of behavior it is showing? Acidic or basic?
Acidic.
It is giving electrons, right? So what type of behavior thing? सोच के बताइए, ऐसे मत बोलिए कुछ भी.
Yes, sir.
आप ना बेवकूफ हो बिल्कुल. आप लोग ने अंदाजी बोल दिया ये चीज है ना. यहाँ पे बताइए, आप लोग का जो दिमाग होगा वो H+OH नेगेटिव वाला होगा. एसिड बेस हम लोग को बस यही दिखता है. सही है ना? यू कैन
Yes,
नेवर
sir.
कंफ्यूज बिटवीन H+ एंड OH नेगेटिव. अब बताइए इलेक्ट्रॉन सिमिलर किसके ज्यादा है, H+ के या OH नेगेटिव के? What is the electron more similar to, H+ or OH negative?
OH negative.
Can all of you see that? Yes or no? Please tell me.
Yes, sir.
What about others? Ahmed. Okay, Ahmed said yes. Faisal, Fatima, Nazira. Can all of you see that electron is more similar to OH negative? Yes or no?
Yes, sir.
Right? Why? Why it is more similar?
Negative charge.
Negative charge, right? So if the manganese in +2 state, it can only lose electron, and that is why it can show a basic behavior. Got it? Yes or no? Right? And if it is in +7, that is the highest oxidation state, then it can only move further up by doing what? By eating a pair of electrons. Okay, by eating a pair of electrons. Now you tell me, which of the following will eat a pair of electron, H+ or OH negative? Which will eat
H+.
electron? H+. So acidic behavior, yes or no?
Yes, sir.
Okay, this is the reason that you will write here. So oxidation, lowest oxidation state will have low oxide. Okay, this lowest oxide is basic and the highest is acidic. Why? The answer will be, what will you write in the answer? Tell me. You'll write, since in low oxidation state, the transition metal can only be involved in, can only be involved in, what it will be involved in, losing electrons or gaining electrons? Losing electron, right? Because it is in low oxidation, involved in losing electron, and hence show basic behavior, and hence show basic behavior. Okay, then you will write, but in high oxidation state, the transition metal can only be involved in gaining electron, and hence show acidic behavior. acidic nature. Okay, so write this down. Let me know if you're done. You can also write an example of manganese only. MnO is basic, but Mn2O7 is acidic. Okay, this is acidic. Write this down. Let me know if you're done. Please write this down. Let me know if you're done.
Yes, sir.
Done, all of you?
Yes, sir.
Right, next, that is the magnetic properties. Okay, magnetic properties. Now, you know, there is two type of magnetic properties can be shown. It can be either paramagnetic or it can be a diamagnetic. Okay, so substance containing substances with unpaired electron are called paramagnetic. Substances with no unpaired electrons are called diamagnetic. They're called diamagnetic. Okay, then there is a unit. There is a unit to measure the magnetic property. Okay, that is known as mu, and mu it is known as under root of n into n plus 2. Okay, where n is equal to number of unpaired electrons. Okay, number of unpaired electrons. You got it? Yes or no? Please tell me.
Yes, sir.
Okay. Wait a second. And this will be in the unit as Bm, which is known as Bohr magneton. Bohr magneton. Okay. I hope some of you just remember this from the 11th standard, electronic configuration, atomic structure. Write this down, then we will give you some question to calculate the magnetic character and the magnetic moments of different elements. Mu is known as the magnetic moment. Mu is magnetic moment. अभी तो म्यू आप लोगों ने फिजिक्स में पढ़ा होगा ना, मैग्नेटिक मोमेंट, नो, यस, मैग्नेटिक प्रॉपर्टीज नहीं है, ओके,
Yes, sir.
don't
We
remember
have
that,
studied.
not studied, okay.
Yes, sir.
Done all of you? Okay. Any questions? Write the electronic configuration and calculate the magnetic moments following. Okay, A is Cr2 positive, Cu positive, Cobalt 2 positive, Mn2 positive, zinc 2 positive. So right, nickel 2 positive.
Yes, sir. Done.
Have you done? Yes or no?
Yes, sir.
So Cr2 positive. Chromium. What is the atomic number for chromium? 24, right? Chromium
Yes.
is 24, right?
Yes, sir.
So Cr2 positive will be how much? 3D?
3D4.
4. Yeah. 3D4. How many unpaired electrons?
4.
4 unpaired electrons. So mu will be equal to under root of 4 into 4 plus 2 is how much? 6.
24.
So this will be equal to
24.
2 root 6, right? है ना?
Yes, sir.
इस जितना हो सके उतना आप लोग, and also this will be in Bohr magneton Bm. Just simplify how much you can. Okay, copper 2 positive. So copper is what? What is the atomic configuration for copper? Copper is essentially 4s1 3d10,
Yeah.
right? Now here
Yes,
it will be 3d
9.
9.
9. How many unpaired electrons?
1.
How many unpaired electrons, guys?
1.
हमें बता दिया आपने. फातिमा, अमल्या, नहीं अमल्या तो नहीं है क्या आज? नाजिरा, सानिया. Yes, Faisal.
1.
1 na, all of you. Yes or no?
Yes, sir.
Yeah.
Yes, sir.
1, 2, 3, 4, 5, 6, 7, 8, 9. So this will lead to 1 unpaired electrons. Okay, 1 electron, and mu will be equal to under root of 3. Bohr magneton. ये होगा ना, 1 into 1 plus 2 is equal to 3. Next is cobalt. Cobalt, what is the atomic number for cobalt?
27.
Oh, 26, 27. Yeah. So this will be 3D. 3D7 na?
3D5. Yeah, 3D. No.
3D7 होगा ना?
3D5.
Cobalt is
Yeah.
4s2 3D7.
Yes, sir. Yes, sir.
डी से निकाल दीजिए बस आप इलेक्ट्रॉन, है ना? 4s कहाँ जाएगा? 4s का इलेक्ट्रॉन निकलता है 3d7. Okay, how many unpaired electrons tell me?
3.
3 unpaired electrons. Okay, 1, 2, 3. So 1, 2, 3, 4, 5, 6, and 7. So this is giving me 3 unpaired electrons, and the mu it will be equal to root of 3 into
Root
3 plus
15.
2, 15. Root 15.
15.
Carbon electron. What about manganese? 3d5.
3d5.
How many unpaired electrons? 5 electrons.
5.
And mu will be equal to 5 into 7.
35. Roots 35.
Bohr magneton. Zinc is 3d.
10.
How many unpaired electrons?
0.
0 unpaired electrons. Okay, and that is why mu will be equal to 0. Nickel.
3d8.
3D2.
3d.
3D8.
3d8. Yeah.
2
So how many
unpaired
unpaired electrons?
2.
How many?
0. No.
2.
2.
2 भाई. Odd even में मत चलिए. ठीक है. This is the d or by 2 d subshell. There you fill the electrons. 2 electrons, and this will be mu is equal to 2 into 2 plus 2 4. So this will be 2, right?
Root 8. Yes, sir.
Root 8.
Root 8. This is equal to 2 root 2, if I am correct. 2 root 2,
Yes.
no?
Yes.
2 root 2. Bohr magneton. Okay. Just a couple of more things. So just write the following. Have 0 unpaired electrons. Okay, 0 unpaired electrons. What are those? You have scandium plus 3, 0, and then you have titanium plus 4. This is also 0, and this can be shown. These are d0. Okay, and then you can have copper plus 1, because copper is 4s1 3d10. So if I remove just 4s1 electron, there will be 3d10, right? So copper plus 1 and zinc plus 2. Okay, these are d10, and that is why these have 0 unpaired electrons. Okay, so please write these 2 points for d0 and d10. Vanadium plus 3, titanium plus 4, copper plus 1, and zinc plus 2. Done?
Yes.
Okay. Next is color. How many of you remember color के बारे में? Or why do we see color? Why do we see color? I hope you remember that I have explained this in the coordination compounds chapter. Why do we see color of anything? Yes, Fatima. याद आ रहा है आपको? नहीं. Why there is a, why do we see color? How do we see color? Not why. How do we see color? It's better framing. Yes, Abir, Ahmed, Fatima, Faisal, Nazira, Sania.
So due to different energy levels.
Okay, fine. Explain a bit more. A few questions there will be now. Different energy levels of what? Reflects them. Reflects. No, I don't think. हाँ ऐसे तो आप लोग ना बस buzzword डाल दो है ना. Ahmed is like visible spectrum. No context, nothing. Visible spectrum. Is there any other word that you know? I don't want these words. Fatima, reflection is not the correct word for it. Okay, reflection is not the correct word for it. No, नहीं ये words सब मत इस्तेमाल करो ना, please. Okay, don't use just these words. Just okay. Turn the mic on and explain me. I have explained you guys for sure. इतना तो I remember. ये देखिए. Color in coordination compass के current सबका color बताया था हमने. Then complementary colors also. Do you guys remember Fatima, Nazira, Tania? कुछ नहीं ना. Notes देखिएगा तब तो याद रहेगा. If you will not revise, then how will you remember? चलिए, no problem. हो गया? दिमाग लगा लिया सबने, तो फिर चलते हैं, देखते हैं. Why do we see color in anything? Why do we see color in anything? Okay. First and the foremost condition for color is availability of light. Okay, there should be light present. Light should be present. Okay, if you don't have, if there is complete darkness, will we see anything? Will we see any color if there is complete darkness?
No.
No, we can't see anything. So light is a condition. Light should be there. What happens? So let us suppose there is a surface here, and we have kept a blue object. So why are we seeing this as blue and nothing else other than that? Okay, why is this blue color? How can we see this blue color? Now this white light, it is coming up, and this is not just white light, it is rather with GO. Is that right? Yes or no? Please tell me.
Yeah.
Right?
Yes, sir.
Okay. Fatima ko yaad aa raha hai. Then
Yeah,
what
this is
happens?
giving me a deja vu. We have done this before.
Yeah, exactly. We have done this before. ये तो हम भी बोल रहे हैं, we have done this before. Okay. Then light comes, strikes the surface. What happens? Now all of these are it has some wavelength, right? The violet has some wavelength, indigo has some wavelength, blue has some wavelength, green has some wavelength, yellow, orange, and red. All of these, they have some wavelength. So some of them get absorbed. Okay, some of them, let us say, they got absorbed. So if I'm seeing blue color, then obviously what will happen? Somewhere around this green, yellow, and orange, these in this surface, what happens? Green, yellow, orange, red got absorbed. And what else? What did happen? This violet, indigo, and blue, this was reflected back. Okay, this was reflected back, and that is why we can see only when the light strikes, then only we can see it to be somewhere around the blue color. Why? Because these colors got absorbed. Okay, these got absorbed. Everything it reflects. Okay, not only mirror. The mirror, it reflects all the light that is coming to it. Okay, but all of the other objects, they absorb something and they reflect the other. They reflect the others. Okay, so here you understand that why is light present. Okay, why is light present? Now it is getting absorbed, so there must be something happening now. These lights are getting absorbed. Now who will absorb them? There are electrons, right? So there are different energy levels. Now all of you said right terms, but you have to condense them in a form, right? So there are multi levels of energy. When you have atoms, there is 1s, 2s, right? Then you have 2p, 3s. All of these are energy levels. So these electrons, these absorb energy and they move to a higher orbital. So as till the time you are giving it light, the electrons are getting into higher and higher levels, and then the energy is getting absorbed and the light is getting reflected back. Okay, so the first thing is that there should be some energy levels, right? And there should be some electrons present in the valence shell which can move up and down. Okay, which can move up and down. So we have got to the conditions, like there should be some energy levels and all. Okay, now let us look at the condition. So here we'll write most of the transition metal ions in solution and solid state impart color. They will impart color. Okay, why this happens? This is usually due to this is very important, partial absorption of visible light. Okay, so why do we see color? Due to partial absorption of visible light. And the remaining of visible light which did not get absorbed, it gets reflected back, and that is the color that we see. Now this absorbed light, okay, the absorbed light, what does it do? The absorbed light, it promotes the electron. From one orbital to another in same d subshell. Okay, in the same d subshell. This is known as DD transition. Okay, so one word answer that you will remember. Why do the D block elements, they show color, they impart color? So one word answer is due to DD transition, due to DD transition. Okay, you got it? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. So write this down. You don't have to write this part above part. Okay, इतना ये लिख लीजिए. D block elements से ये related है. Now, so write this down. Then we'll conclude one more thing. Then guys,
Yes, sir.
Yes, sir.
first thing is that there should be some electrons in the d subshell and there should be some vacant orbital, right? There should be some space left in the orbitals in the subshell. Okay, that means there should be some space left in the subshell for the DD transition to happen. And that is why I can write one more point that please write this with me. Okay, please write this with me. Only those, or rather I should say, wait a second. Fully filled and subshell with 0 d electrons don't impart right. Now, if it is fully filled, that means there is no space left for the electron to move. So there will be no d transition. And if there is no d electron, then obviously there is no electron even to move here and there, right? For the d transition. That is why only substances with incomplete d subshell impart color.
Yes, sir, done. Except for last one.
Except for the
Last one.
last. Okay. Yeah, last one. I mean, even if you tried it and you did it, it would be a bit. It would not be very right. Okay, because there is some other concept used in that. ये एक सवाल है आपका NCERT में. That is why I have given you this, even though the concept is not there in NCERT. Okay, for Mno4 negative. So yes, can you please all of you turn the mic on? Abir, Ahmed, Fatima, Faisal, Nazir, and Sania.
Yes,
Tell me about titanium. Colored or not colored?
colored.
Colored.
Colored. Ti 3 plus is colored. Okay. Vanadium 3 plus
Colored.
colored. Vanadium
Not
3
colored.
plus.
Not
Not
colored.
colored.
Okay, very good. Not colored. Mn2 plus
Colored.
Colored.
colored. Fe3 plus
Colored.
colored. Okay. Now let us look at MnO4 negative. Now, if you remember redox reaction and how you know how to calculate the oxidation state, then you will say that Mn will have X oxidation state plus oxygen will have 4 into -2, and this will be equal to -1. Right, guys? Yes or no? Yaad aaya? I hope you guys remember redox reaction now, how to
Yes,
calculate
sir.
the oxidation state. Very good. Now, what will be X here? X will be equal
X
to,
would be 7
Plus
plus
7.
7.
very good. X would be +7. Now we are having this manganese is how much? +7. Manganese is +7. Now you tell me, what will be the configuration? Manganese +7. This will be just argon, right?
Yes, sir.
Yes or no?
Not
Because
colored.
manganese is 3d5 and 4s2. All the 7 electrons have been removed, correct? Right, guys? Yes or no?
Yes, sir.
Yes, sir.
Now, here, the thing that happens is we have manganese, right? And we have O4. Now, in MnO4 negative, there is bond between manganese and oxygen, right? There is bond between manganese and oxygen. Now, in manganese and oxygen, what happens? There are lone pair electrons of oxygen, and there are vacant d orbitals because all of the d subshell is vacant here, right? So there is vacant d orbital, and these lone pair electrons they interact with this d orbital here. Now, this is known as charge transfer. This is known as what? This is known as the charge transfer, and this charge transfer is happening from what to what? From ligand to metal. So this is colored. Here you will write due to ligand to metal charge transfer. Charge transfer MnO4 O negative is colored. Okay, so just be careful of this example. Others are just gases, ions. Okay, they will not. There will be no. There is no ligand, so there is no question of ligand to metal charge transfer. Okay, so in MnO4 negative, what is happening? A charge transfer is taking place. Okay, a charge transfer is taking place, and that is why you can also not. You will not be getting MnO4 negative. You can get KMnO4. Okay, so please remember KMnO4 and MnO4 negative is same thing only, right? Here we have potassium atom. That is why K plus. That is why this negative charge is not shown. Okay, both of these are same. What is the color? Have you seen KMnO4? Yeah, nahi.
Purple.
Purple.
Purple. This is purple color, correct? तो होता तो है color,
Yes,
है ना?
sir.
ठीक है, चलिए. Okay, guys. So that is it. अच्छा नहीं, एक सवाल और कर लेते हैं. That I think is important, and then we can leave. Okay, for today.
So can you show the answer of MnO4 negative?
क्या ठीक से तो बोलिए. MN कर रहे हैं बस आप.
MnO4 negative.
नहीं तो रहा, लिख लीजिए.
Yes, sir.
Sir,
हाँ बताइए.
sir, what is the meaning of ligand?
लिगेंड का मतलब भाई ये कोऑर्डिनेशन कॉम्प्लेक्सेस में, कोऑर्डिनेशन कंपाउंड्स में है. So
Okay, sir.
ligand is anything which is binding to a metal. Okay, something which is bonded to metal, a D block metal in complex compound. Okay. Have you seen? You have seen, right? Mno4. So in this Mno4, this oxygen is what? Oxygen is the ligand of manganese. Okay, oxygen is the ligand of manganese. Anything which gives electron, it is known as ligand. Okay. There is bonding, coordinate bond. Na? So in coordinate bonds, if you have A, B, so this B is the substance or the element which is accepting electrons, and A will be the ligand. Okay.
Yes, sir.
Present? Okay. Write the stable oxidation state of transition metal with following d electron configuration in ground state. CD3. Okay. First of all, let me tell you about this question. What is this asking? They are saying that what will be the stable oxidation states? Okay, what will be the stable oxidation state? कौन से ऐसे oxidation state हैं which can be stable for a transition metal with the following d electrons? So how many d electrons are here? 3 electrons are there in the d orbital, and they are also saying that it is in the ground state. That means it is neutral. Okay, it is not a charged species. So you don't have to think about the charged species. Here we are having 3d3. Here we are having what? 3d3. So now you tell me, if there is 3d3, then obviously the metal will have argon 4s2 3d3, right? Because if it has 3d3, then it also have to have the 4s2 electrons. If it does not have 4s2 electrons, then 3d3 will not be there. Yes or no? Please tell me that. Correct?
Yes, sir.
Right. So here you can see that in 3d3, right? So we have how many electrons that we can? There are 4s2 and 3d3. So we have 5 electrons. We will start with what? We'll start with +2. It can show +2 oxidation state. Why +2? Because it can remove the 2 electrons from the 4s2. Then it can also remove one more electron to give +3. It can remove one more electron to give +4. It can remove one more electron to give +5 oxidation state. Okay. So 3d3, the metal is vanadium. Okay, and these are the oxidation state that can be exhibited by vanadium atom. Okay, this is how you are going to do this problem. B is if you have 3d5. Now 3d5 is important. Okay, 3d5 is important. Why is it important? I will tell you. Because in 3d5 there are two options. It can be 4s1 3d5. It can also be 4s2 3d5. 4s1 3d5 will be for chromium, and this will be for manganese. Yes or no?
Yes.
Yes, sir.
Right. So if you have been given 3d5, then you will do it like this. And then chromium, it can give you +1. Yes or no? Can it give you +1? +1 नहीं देगा, यहाँ से प्लस स्टार्ट करता है +3 से यहाँ पे. Okay, it starts with +3. If you look at the table, it starts with +3. Then after +3, why +3? It is very easily, because if it shows +3 oxidation state, then what will happen? It will have D3, and D3 it has T2G3, right? It has T2G3. That is why +3 is very stable for chromium. +3, and then it will show +4, and then there are 6 electrons. No? So then till +6 it will show. It will show till +6. Next, manganese. Manganese starts with.
So what about +2?
+2 for chromium. +2 to +3 goes very easily from +2 to +3. That is why it is not very stable. Chromium में तो ये याद रख लेना. We have done. This is the third question that we are dealing with, right? In chromium. First
Yes.
the table, right? Then we have the oxidation state of iron, the reducing nature of iron and chromium, and then here we are having again 3d5. So in Mn you will have +2, then followed by, if you look at the oxidation state of manganese, +2, and after +2 it directly has +4, followed by +6 and +7. These are the oxidation state which are stable for manganese. The important thing is that you have to concur this idea about 4s1 and 3d5. See point. Let me write. If you have been given 3d4, then you will say that no transition element, no transition metal has 3d4 configuration, right? There is no one with 3d4. Chromium would have been 3d4, but it is 4s1 3d5. That is it. Write this down. Let me know if you're done.
Done, sir.
Yeah. Okay. What about others? Done?
No, sir.
Malik,